Hello guys, welcome to this video. In this video, I'm going to discuss about accelerator agnostic. So first of all, let me tell you what is accelerator agnostic. So if I talk about this, JAX is totally based on accelerator agnostic because the same code runs everywhere. Suppose you have taken an array uh, with a CPU format, but you want to pass it to your GPU. So what it will do, it will automatically try to convert your array to the GPU format, uh, or it will automatically push your array to the GPU accelerator, so that you don't have to write any specific code for that. Uh, if you know PyTorch, so in PyTorch you will be saying if we want to pass a, you can say, numpy array to our PyTorch. So what we need to do, we need to convert it to the device first of all. Like suppose you have selected the GPU, so you have to also convert it to the GPU format. That means you have to convert it to the tensors, then you can pass it to the PyTorch. But here, this function is not required. This to device, I think if you know the PyTorch, so I think you will be familiar with this function, that is to device. So what it does, it will try to convert your array to the tensors. That means your accelerated device. But in JAX, it is not required. Suppose you have selected your GPU, so what it will do, automatically it will convert your array to the GPU, we can say, format, uh, or it will automatically optimized your array to the GPU format, so that you don't have to write any specific code for that. And also, suppose you have changed your runtime to TPU, so what it will do, it will automatically try to, you can say, push your arrays to the TPU format. Okay, so that is the advantage. That is the advantage in JAX library. Uh, so here I'll be showing you some experiment, and here also I'm going to show you some comparison between JAX and NumPy. Here I'm going to do some calculation, and we'll be seeing which library does the same task in a short time. And here I'm also going to show you this accelerator agnostic, uh, so that you can get the idea like what I'm saying. So let me run the code. So here I have imported my JAX and NumPy and some of the helper function I have imported. And here what I have done, I have kept my seed and key, because in the previous video I have already shown you, if you want to take a random number in JAX, so you have to pass the key. So that's why I have taken a key and I'm passing it here, because see here I'm taking some random number, and also I'm taking some random number from NumPy. But in NumPy you don't have to mention the key. Instead of, you have to define the size. So I'm defining the size, and also you can say I'm making the data type to float 32. So some, you can say, syntax might be different, but almost they're same. Okay, sometimes it might be different, but majority of the, you can say, syntax are same. You can say this NumPy and JAX. Now what I am doing, here I have done some timing operation. Actually, I just want to check the calculation time is happening in this JAX and NumPy. So first of all, I'm calculating this dot product in this, you can say, JAX library. So see, here I have passed my this array in this my JAX, you can say, JAX dot function. So what it will do, it will do the dot multiplication, and the same thing I'm also doing with the help of this NumPy, and it will run definitely on CPU, because NumPy runs on CPU. But if I talk about the JAX runs on this JAX runs on multiple devices. Uh, so here we have selected the GPU, so it will run definitely on the GPU. And also what I'm doing here, I'm doing this, you can say, accelerated agnostic, because see, so here you can see I have directly passed my NumPy array to the JAX. Actually, I haven't converted this NumPy array to my JAX accelerator. Instead of, I have directly passed that. So what it will do, first of all, it will convert your NumPy array to your, you can say, accelerator. Okay, like whatever accelerator or whatever device you are using, whatever AI accelerator or whatever device you are using. So it will first of all convert it, then it will do the multiplication. So let me run the code. So see, it is running. First of all, it is calculating this, you can say, dot product with the help of this, you can say, JAX library. And see the and see the, you can say, runtime. Okay, so it is like 25.9 millisecond per loop. And the second function, here I am using the numpy for calculating the dot product, but it was, you can say, taken, see, 424 millisecond per loop, so that is huge. uh, and here what I have done, I'm directly passing my numpy array to my JAX. So it is first of all it is converting to so first of all it is converting my array to your, you can say, AI accelerator, that means to your device. Then it is like doing the calculation, so that's why it took a, you can say, a higher time than the previous one. And so here there is a solution. If you want to reduce that time, so there is a already built-in function called device put. So here I have imported that function. So if you pass your, you can say, numpy array in this device put, so it will convert it, you can say, to the GPU accelerator. Then if you pass it here, that means the same one like I have done, you can say, number one. So here, see, there is the same thing I'm doing, but here I'm putting my array after done this device operation. And see, that is the result. So that is the same result, okay, like my previous one. So now I think you got the idea why we call it accelerator agnostic, because here you are not, you can say, converting, you can say, this numpy array, I mean, specifically to your, you can say, JAX format, I mean JAX data format, I mean your, you can say, AI accelerator format. Instead of what you are doing, you are directly passing that, and this JAX is automatically handling these kinds of operation. So yes, you can say that is the, you can say, advantage part of this JAX. But if you use this, you can say, PyTorch, so there you have to first of all convert your numpy array to the tensors. Then you have to also, you can say, set your device, also set your device to the GPU. Then you will be converting. Then you can pass to your PyTorch, you can say, function. But here it is not required. You can directly pass that, so it will automatically do your job. And here you will note one thing, because here I'm using GPU as my, you can say, synonym for AI accelerator. But in reality, there might be, you can say, different device, like there might be TPU also, or you can say another device also. So it will do the job with respect to your selected, you can say, AI accelerator. So I think you got the idea. And this was all about from this video, and I will be coming up with a new topic in our next video. Thank you.